Hey guys, welcome back to another episode of Math Unlocked with Mrs. Rhodes-Grierson. So today we're looking at evaluating functions. Let's talk about what functions are. So I see the statement f of x is equal to 2x squared plus 1. What does that mean? Because we have to understand what the things mean for us to make sense of them, right? So f of x means that there is a function called f, and it's a function of x, meaning that I will see x as my input value in that statement. So once it says f of x, it means x is involved in the statement. It could say f of t, it would mean t would have been involved. If you want to say f of z, it means z would have been involved. But it says f of x, so x is involved. X is the input value. So if I'm supposed to process anything here, I will put x in and I will get an output value. There's another way that I could have written f of x be equal to 2x squared plus 1, and this is the next statement. I could say f is such that x maps to 2x squared plus 1, meaning the same thing that is expressed here, but in another notation, I'm saying that the function is going to map the x value onto another value based on when I put the input value in. Or we could go ahead and just state what is the output value. The output value is also given a letter, and we generally, when we use x, we use the pair of y. Hence generally when you see a coordinate pair, you will see it written as x comma y, meaning that putting an input of x will produce an output of y, and they're recorded as a coordinate pair. So we can replace f of x with y because f of x and y are representing the same things. They represent your output. So let's see how we actually evaluate a function. Let's say I told you that x is 9. So what is y? I am asking you for the y value when x is 9. It doesn't mean that x is always 9. It means that I'm evaluating y when x is 9. So let's check that out. Since y is equal to 2 times x squared plus 1, I'm going to substitute. I want to know what y is. Since y is equal to 2 times the x value squared plus 1, and the x value in this case is 9, I'm substituting 9, replacing the x value with a 9. Order of operation said do your exponents first. So that's 2 times 9 times 9 plus 1. A number squared means to multiply it by itself. So that's 2 times 9 nines is 81 plus 1. So that is 2 times 81. So that's 2 times 81, which is 162 plus 1, which means that's 163. So y is having a value of 163 when x is 9. I know that a lot of you will tell yourself, when you're working out the question, and I don't know why you tell yourself these things, when you're working out the question, you see a big number and you ask yourself, I think this is wrong, the number looks too big. Ensure that if you're following the correct process, you're doing your process properly. Remember that numbers can be big and they can be small. So you don't tell yourself that the number is automatically supposed to be small because you were not told so. So here is my ordered pair. 9 is the x value that I inputted into the statement. 163 is the y value, which is my output that was matching this particular input. So what we want to check is confirm that x and y doesn't remain a constant. The value of y changes based on the value of x, but I must use this statement. Now let's explore this one. What is y when x is equal to negative 2? I like to include the negatives, because that's where you have the trouble. So we have to work on the troubled areas, right? What is y when x is negative 2? I expect to get a different result from the one before now because it's not the same x value. So I expect as x change, y should change as well. So what's y? Since I'm going to be using the same statement that says y is equal to 2x squared plus 1, I'm going to then say y is equal to 2 times what? Square plus 1. X is now negative 2, so I'm substituting negative 2. Notice how I put my substitution in a bracket and everything else in the statement comes back because all I'm replacing is x, nothing else. I'm going to go ahead and do my square exponents first. So that's negative 2 is multiplying negative 2 plus 1. And negative times a negative, let's stress that one. And negative times a negative will always produce a positive. So that's positive 4 coming from negative 2 times negative 2. Simplifying, doing my multiplication before I add. That's 2 times 4 is 8, and 8 plus 1, that's 9. So now I see that y has a value of 9 when x had a value of negative 2. So my ordered pair would have been negative 2, comma 9. I write my ordered pair in terms of and what we also call a coordinate pair. X comes first at all times, a comma separates the 2, and y comes second. So this is my x and that is my y. Or this is my input and that is my output. Because it's not every single time that a function will say x and y. They could use other letters to assess the function. Let me add a little brata to this video. Is that sometimes instead of writing the statement as explicitly as it would have been written before when it says what is y when x equals 3, another way they could have asked you for the very same thing is to say f of negative 2. We look at this and we need to understand what it means. This is saying for the f function, see it here, same as this one, for the f function, it was f of x. Notice this says f of negative 2. It means that with this, in the function f of x, I should replace x with negative 2. Just as though I would have said, what is y when x is negative 2? This is a shortened way of asking you the very same thing. So f of negative 2 is saying, what is y when x is equal to negative 2? You do your substitution. So you say 2 times negative 2 square plus 1. We can ask you one thing in more than one way.